All right, everybody. So today we're taking a look at the second half of this section here that we started last week, I guess. So we're trying to take a look at calculating the areas of trapezoids, rhombuses, and kites. And really, one of the things I keep coming back to throughout our time in this class is being able to break shapes up into familiar shapes you already know how to deal with. Okay, so in this first part, it asks us to cut out and redraw the trapezoids below. Or redraw it, sorry, to try to rearrange them in a shape that's easily calculated. Now, if you haven't done that already, please feel free to push pause and see where we're going to go with that. Maybe try to see if you can get that going here. Okay? But I'll give you a second and then I'll start explaining it. All right, so if we're taking a look at the shapes down below here, we've got these two trapezoids right here. Okay? So for this thing right here, these are congruent shapes. I just copied and pasted them next to each other there on top. So with this thing right here, what I'm going to actually see is that if I took these two shapes and I took this top shape here, okay, and I don't know if I can really do this here, but if I took this and flipped it over and linked it up so that it laid right on top of this thing here, it would look something approximately like this, where this is going to be base 2 and this is going to be base 1. It's definitely off there. And this would be the height that we have in this thing, that right angle. Okay, so flipping on top of each other. And despite my terrible drawing here, you should be able to see that this is going to be a parallelogram. Okay? And we know that from our work previously that the area of a parallelogram is going to be base times height. And so for this thing right here, if we're taking a look at a parallelogram and we're trying to go through and find the area of this thing here, we can see that the base times height is a little bit different because in this case the base is going to be b1 plus b2, the bottom base that is, times the height, which is going to be h here. Okay? But the problem that comes up with this thing is that this is actually twice the area of the original shape there. Okay? So in this case right here, if I want to go ahead and solve for the area, I would divide both sides by 2. So it's just the area of one of these shapes. Okay? So kind of weirdly drawn in there, but the area of this is going to be b1 plus b2 times h over 2. So another way to think about this is it's the average of the bases, so b1 plus b2 over 2 times the height. Okay, so that's one way to take a look at this thing. So that's going to be the first part here for working through the areas of the trapezoid. Okay. The next two shapes that we're taking a look at here are we have a rhombus and we have a kite. And so it's up to you how you want to do this thing. My suggestion here, which it says up top here, is to cut out the kite below, cut out the kite below along the dotted lines, and rearrange them into a familiar shape whose area is easily calculated. Okay, so you have a couple of different ways to go about that, and this is just one of them. But if you were to do this thing, and say you took this side of this triangle and put it over here on this side, it would create a rectangle. Okay, and same kind of deal here. If I took this and I moved this shape over this side, I'd end up with a rectangle here. And you'd end up with something that looks approximately like this. And so in this thing here, we can see that this is x here, obviously all the way across here, this is x, because that was that piece. Over here, this height is y. Okay? As it is over here, it's a rectangular shape here, obviously. So, and then we have z being the height down here. So if we want to find the area of this shape, we could break it up into a bunch of different pieces, or for the area of this thing, we could go ahead and take a look at it as a rectangle, where this is going to be x times y plus z. And that would be the area of this whole shape here. Okay? And so there's different ways to go about that. That would be one way to look at this thing here. In this problem here, I have it set up so that y and z are two separate values. But if you look at them originally, the diagonal was y plus z. Okay? Like this bigger diagonal right here is y plus z. So if in the original problem I had kept that as the diagonal, and you could definitely use this formula here if you can rearrange it correctly. But if I see that here that y plus z is going to be equal to diagonal 1, and diagonal 2 is going to be x plus x, or just 2x for diagonal 2. So let's write that's 2x. So if I take a look at this thing here, and I'm trying to find the values that go along with this thing here, I can see that the area is still and instead of x there, if I substituted, or if I solve for x here, I ended up with d2 divided by 2. If I took that and I substituted in here, right here for x, d2 over 2, and y plus z is d1, I end up with essentially this expression. I know it's kind of crammed in here, but it'll be d1 times d2 divided by 2. Okay? And that's the version that the book gives you, or actually they write it as 1/2 d1 times d2. But really, keep in mind when you go through this thing here, if you're doing a kite, you could definitely just go ahead and break it up into shapes if you can make that work here. And this is just one explanation of it. The book has a pretty neat explanation with their diagrams and everything on page 679. And so it's definitely worth looking at there. Hopefully you're going through the book anyway, but they just break it up into a top triangle, or essentially a left triangle and a right triangle in this thing, and take a look at those and adding those two areas together. Same thing can be said over there for the rhombus, where you can go through and break it up. What's neat about this formula that we have right here, the area is equal to d1 times d2 divided by 2, or 1/2 times d1 d2, that actually works for both the rhombus and for the kite. Okay, so it works for both those things here. So for a rhombus, or HOM, and the kite, the area is going to be 1/2 d1 times d2, okay, or it's the same way I wrote it down there at the bottom. Whether you break some into shapes or use the formula, they're both going to work here. There might be some limitations, I think, in the homework where it's going to be nice to have the full diagonals, but you can do the best you can to break it up into familiar shapes. Okay? All right, so hopefully that helps you out. And so tonight's homework, and for the rest of your asynchronous time here, is to just go ahead and work with these formulas. I'll post our solutions already posted on there. Work with these formulas and finish the rest of this worksheet. Okay. Hope everybody has a good weekend, and I will see you all on Tuesday when this is all due.